Hello, ladies and gentlemen. As promised in class, I am going to demonstrate the derivation of the identity cosine A plus B. It is a rather lengthy derivation or proof, if you will, but it's not really that difficult per se. So let's get started on that. All right, to begin this proof of cosine A plus B, I have my circle here, and this is a unit circle. So therefore, ladies and gentlemen, it is a unit circle, and because of that, the radius of this unit circle is understood to be 1. So the radius of any angle in this unit circle is going to be 1. And we discovered, because it's the unit circle, the x and y coordinates of any point around this unit circle are going to be equal to the cosine and the sine of the respective angle in standard position. All right, first of all, what we're going to do is we're going to have an angle here. We'll call angle A. I'm going to call this point here O, and I'm going to call this point right here P. Now, the coordinates of point P right here are going to have, for an x coordinate, the cosine of angle A, and the y coordinate of this point P is going to be the sine of angle A. Again, that's the case because we have the unit circle where the radius is 1. All right, I'm also going to have another angle down here, which is going to be angle negative B. And this point out here is going to be called point Q. Its ordered pair address is going to be the cosine of negative B, and the y coordinate will be the sine of angle negative B. Which, ladies and gentlemen, we know, because the cosine is an even function, we know the cosine of negative B is the same thing as cosine of B. And the sine function being an odd function, the sine of angle negative B is going to be the opposite of the sine of B. In other words, the negative of sine B. I'm going to connect points P and Q, and we can see that we have a triangle here. Okay, we have a triangle. If I take this angle A here, and if I rotate it counterclockwise B degrees, all right, if I rotate this angle A B more degrees, terminal side, let's say, lands in the second quadrant here. So rotating angle A B degrees more, we now have an angle from here to here, which is going to be A plus B. A plus B. I'm going to call this point up here point P prime, because when I rotate angle A B degrees more, this point P is going to move around the unit circle and join up with this point P prime. Likewise, if I rotate angle A B degrees more, this side of this triangle here is going to rotate B degrees. So this point Q is going to rotate up here and going to become point Q prime. Now, the ordered pair address of Q prime is going to be the ordered pair 1, 0. And the ordered pair address of P prime here, since this is angle A plus B, is going to be the cosine of A plus B. And then the y coordinate will be the sine of A plus B. And I'm going to connect points P prime and Q prime with a line segment. And so now we have another triangle. So ladies and gentlemen, we got two different triangles in this picture here. We have the triangle POQ, And we got the triangle P prime O Q prime. Well, these two triangles are congruent to each other. They're congruent to each other. And being the case, ladies and gentlemen, it must be true then that the length of side P prime Q prime would be equal to the length of the triangle, which is side PQ. So again, the length of side P prime Q prime, the length of that line segment would be equal in length to the line segment PQ. How do we find the length of a line segment in the XY plane? Well, we use the distance formula. And recall the distance formula between 2 points, x sub 1, x sub 2, and x sub 3, y sub, x sub 1, y sub, x sub 1, y sub 1, and the point x sub 2, y sub 2. How do we find the distance between two unique points in the plane? We use the distance formula. And so the distance is between these 2 points would be the square root of the sum of the squares of the differences between the coordinates. That's to say the distance between these 2 points would be x sub 2, the square root of x plus x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared. That's the distance formula for any 2 points in the plane. We've seen that before. We're going to apply the distance formula here to represent the length of line segment P prime Q prime here to here, and also to represent the length of line segment PQ. So what would be the length of line segment PQ, P prime Q prime? Well, it's going to be the positive square root of the square of the difference between the x coordinates of P prime and Q prime. That's to say cosine A plus B minus 1 plus the square of the difference between the y coordinates of points P prime and Q prime. That's to say sine of A plus B minus 0. Well, ladies and gentlemen, that length, which is the length of P prime Q prime, has to be equal to the length of PQ. So the distance between points P and Q is going to be the positive square root of the square of the difference between the x coordinate of point P and the x coordinate of point Q. That's to say cosine A minus cosine B. Plus the square of the difference between the y coordinates of point P and Q. That's to say sine A subtract the negative sine B. Well, sine A subtract the negative sine B is sine A plus sine B. Therefore, we're now going to simplify this equation. We're going to square both sides of this equation, and when we do so, we will get rid of the square roots. When you square a square root, it disappears. So on the left side of our equation, we're going to be left with the cosine of A plus B minus 1, quantity squared. And sine of A plus B minus 0, quantity squared, or just the sine of A plus B squared. On the right side of our equation, when we square the square root disappears. We're going to be left with the cosine of A minus the cosine of B squared plus the sine of A plus the sine of B squared. Now what we're going to do is we're going to square this. It's kind of like multiplying two binomials together. And to do that, you would FOIL this out. So that means cosine A plus B times itself would give you cosine squared A plus B. Cosine A plus B times a -1 times another -1 times cosine A plus B would give you -2 of those cosine A plus B's. I am omitting the details of FOILing this out. It's just like multiplying this binomial by itself, ladies and gentlemen. We should know how to do that from algebra. And of course, -1 times -1 would give you the last term of +1. The square of the sine of A plus B is sine squared A plus B. And that's going to be equal to, now what we'll do is we'll FOIL this out, expand this out. Cosine A minus cosine B squared is going to be cosine A squared. Cosine squared A, rather. And cosine A times negative cosine B plus another negative cosine B times cosine A will be -2 of those cosine A cosine B. And a negative cosine B times itself is going to be a plus cosine squared B. Finally, we FOIL this out, sine A plus sine B times itself. So sine A times sine A would be plus a sine A squared, plus a sine squared A, rather. Sine A times sine B plus another sine B times sine A would be +2 of those sine A sine B. And sine B times itself would be sine squared B. Back on the left side of our equation, we can see that the cosine squared of A plus B plus sine squared of A plus B by our Pythagorean identity must be 1. So again, cosine squared A plus B plus sine squared A plus B is 1. So we have 1 minus 2 cosine of A plus B plus this 1. On the right side of our equation, ladies and gentlemen, we have a couple of simplifications. Cosine squared A added to this sine squared A would simplify to 1 by our Pythagorean identity. Likewise, we have cosine squared B added to sine squared B would be another +1. Cosine squared B plus sine squared B by a Pythagorean identity is +1. And then we have -2 cosine A cosine B plus 2 sine A sine B. Back on the left side, these ones add together. 1 plus 1 is 2. So we have 2 minus 2 cosine A plus B. On the right side of our equation, 1 plus 1, these combine to give you 2. So we have 2 minus 2 cosine A cosine B plus 2 sine A sine B. Now, if we subtract 2 from both sides of our equation, these 2's drop out on both sides. So we got this thing down to now -2 times the cosine of A plus B equal to -2 cosine A cosine B plus 2 sine A times sine B. Ladies and gentlemen, what I'm going to do on the right side of my equation is factor a -2 out of both these terms. I can factor a -2 out of both these terms separated by addition. So let's do that. So my equation now is -2 cosine A plus B. And on the right-hand side, like I said, I'm going to factor out a -2 out of both these terms here. So we'll have -2 times cosine A cosine B minus sine A sine B. Dividing both sides of our equation by -2, the -2's drop out. And we're left with cosine of A plus B is equal to cosine A times the cosine of B minus the sine of A times the sine of B, and we are done. We have derived, ladies and gentlemen, the sum identity for the cosine function. So cosine A plus B is equal to cosine A times cosine B minus sine A times sine B. That is the complete derivation of this identity. Hope you got something out of that. Of course, the nice thing about this video is you can pause it, rewind it, and go over and over it several times till you understand it. This is optional. You obviously do not have to know how to go through the derivation of this to prove this identity. I'm just showing you this so that you can appreciate where this is coming from. Okay, hopefully you enjoyed it.